Okay, good morning, good afternoon for some of you. Welcome to our town hall for the AAS Committee for the Protection of Astronomy and the Space Environment. We have a couple of minutes right at the beginning with some schedule and housekeeping items, and that'll allow other people to go ahead and trickle in, but we're very glad that you're with us today. My name is John Barentine, and I am the Secretary of COMPASSE, and I'll sort of be your Master of Ceremonies today. Before we get started, I would like to let you know what our plan is for this session and tell you a few of the sort of ground rules about how it's going to work. And then we'll go into a series of presentations that will take up about a little more than 30 minutes. And then the balance of the hour will be used to answer your questions. So can we go ahead and get the question or the slides started, please, Colin?
Yep, I'm on it.
Okay. All right, very good. So go ahead and if you'll take us to the next slide, please. So this is what our run of show will look like today. I'm going to just tell you what these rules are very briefly right at the top, and then I will hand over to our incoming co-chairs of COMPASSE. They will give you a few minutes of introduction to the event. Then we will hand off to the Light Pollution Subcommittee for an update. From there, we'll go to electromagnetic interference for 5 minutes. And then because we are combining our space debris and satellite constellation groups, we're going to give them a little bit more time. Then we'll hear from the policy subcommittee for 5 minutes. And then our community engagement subcommittee for 5 minutes. That'll take us to a bit past the half hour. And then at that point, we will turn over to answer your questions in the Q&A. Next slide, please. So as I said, the Q&A will start immediately after the presentations. There is a Q&A box in your Zoom window where you can drop your questions at any time. Some of them our panelists may answer in that chat window, but we'll do some live Q&A where I will give them your questions to answer live when we go into that formal Q&A session at the end. But you can drop those questions if you have them at any time. We'll try to get through as many of those questions as we can during the live period and do everything we can to get you out of here on time at the top of the hour. And one thing that I would encourage you to consider is signing up for our mailing list, which we've recently set up through lists.aas.org at the address that you can see there on your screen, or you can scan that QR code. We'll remind you about that at the end of the presentation as well. This is just something where periodically you might hear from us with some updates on what we're doing in between events like this one or our events at the AAS meetings so that you can keep informed as to what's going on in all of these topical areas and what COMPASSE is doing about them. And so with that, if you'll go to the next slide, please, Colin, I'd like to introduce our incoming co-chairs of COMPASSE. Those are Professor Samantha Lawler of the University of Regina in Canada and Professor Michelle Wooten of the University of Alabama at Birmingham for their welcome. So I will turn it over to Sam and Michelle.
Thanks, John. Yeah, hi everyone. So Michelle and I are here to introduce ourselves as the incoming COMPASSE co-chairs. We're beginning our term next month in June. So I'm an associate professor at the University of Regina in Canada on Treaty 4 lands. I'm on this committee because I keep seeing more and more satellites moving across my dark prairie skies and streaking up my Kuiper Belt discovery data. So I spend a lot of time focusing on advocating for better regulation of satellites in orbit, better regulation of safety in orbit, and thinking about the pollution associated with launching all these satellites. Michelle?
Hi, everybody. My name is Michelle Wooten, and I teach hundreds of students about astronomy every semester at the University of Alabama at Birmingham. And, I give them these assignments that have them look at the night sky, and half of them can't see it. So I'm on this committee to really help people learn how to use dark sky friendly lighting practices. I'm the dark sky chapter leader for Dark Sky International. The chapter is called Starry Sky South. So if you're in the South like me, I'd really love to connect with you. Being on this committee has been so great for me to network with others who have a shared passion for protecting the night sky.
And yeah, so as the co-leads, we're here to help connect all of you with the resources to get your questions answered about the protection of the night sky. You're about to hear from a bunch of truly amazing people who care deeply about access to the night sky. And all these people are working incredibly hard to protect it from many different threats. So thank you. I'm so honored to work with all of you.
Okay, let's go ahead and get into the topical presentations. We'll do one of these for each of the areas in which COMPASSE is active. And for that, we'll begin with Professor James Lowenthal from Smith College. So take it away, James.
Thank you, John. James Lowenthal here at Smith College in Western Massachusetts, and I lead the Light Pollution Subcommittee of COMPASSE. And if you go to the next slide, you'll see the context. This is an old picture. Most of us in astronomy have been showing some version of this picture for decades, and I don't know exactly when it's from. Maybe somebody on this call does, but certainly back in the late 90s, we were using this picture already, projecting forward, and there we are at 2025. That is shown in the lower right. The prediction for how the United States would look like from space or in a light pollution map. And sure enough, that's where we are. The context for much of our work is unfortunately even worse than this. A recent result by Chris Kaiba on a paper that included Connie Walker, who is here with us today, just a couple of years ago, found from 50,000 citizen science measurements using the globe at night that Connie and collaborators started years ago, 50,000 observations of the sky over the last decade plus have shown that light pollution is getting worse much faster than we thought it was, as fast as 10% per year in much of the US and much else of the world. If you go to the next slide, you'll see now this is a measurement, not a prediction. And I'm happy to see that Emilio Falco is on the call today, who was instrumental in getting this fantastic website up, lightpollutionmap.info, which if you don't know already, you'll soon find how incredibly useful it is. This is a measurement using satellite data combined with some ground-based measurements, confirming our fears, our predictions from decades ago, that east of the Mississippi, essentially the whole United States is light polluted. If you go to the next slide, thanks, Colin. This is a summary of some of the main activities that the COMPASSE Light Pollution Subcommittee has engaged in to try to address this major wicked problem. Four main themes. I want to mention on the right here, you see a list of most of the people who regularly actively participate in our light pollution subcommittee. It's a relatively porous committee, a group, and if you are interested in joining us, please do. We have monthly meetings. In fact, there's a monthly meeting this afternoon in just a couple of hours from now. And on this list, you will see at least 5 people who have won major awards from Dark Sky International. These are really many of the leaders in the world of the protection to save natural darkness at night. So the main activities of our subcommittee are these 4. One, we aim to engage with the members of the American Astronomical Society meeting at AAS meetings through the various formats that already exist, like workshops, special sessions, meeting in a meeting. A little bit more on some of that later. We also aim to engage with AAS members outside of those meetings. We have a website, and we issue occasional emails, occasional action alerts. We're trying to motivate through sharing success stories, because there are success stories, and given our relatively effective networking, we hear from them. We hear when cities or towns or campuses or institutions are able to turn back the tide of light pollution, and we share those stories, often in concert with Dark Sky International. In fact, a lot of the work we do is overlapping with Dark Sky International. we're cognizant of that and doing our best not to duplicate, but to complement each other's work. A third major pillar of our work is a new initiative called Campus Shine. And we've recently done a soft launch of our website. There are three main components to Campus Shine: a website, a how-to document, and a slide deck. All of these are geared towards helping campuses figure out how to fix their light pollution problem. Anybody on a campus who hears that there's this thing called light pollution, whether they're an astronomer or not, they could be an environmental science person or an architecture person, anybody could hear that there's a problem and turn to these resources to get a jump start on how to engage their own campus in the fight to turn back light pollution and regain natural darkness at night. And then finally, we're working to develop national policy on light pollution. And Colin, if you go to the next slide, I'll expand on that one a little bit more before turning it over to Michelle to talk more about Campus Shine. National policy on light pollution, it doesn't exist yet, really. There is no US law on the books on light pollution. There have been some bills in the past, there have been some attempts, but there's currently nothing that's stuck. There's a patchwork of state laws and local laws. The picture at the upper right shows you a map of the roughly 17 states that do have some statewide legislation of outdoor lighting at night on the books, but you see there are many that don't, and it's a real hodgepodge. There is a national rule that says any federal funds that go towards buildings, property, under the aegis of the General Services Administration, the GSA, which, as you may know, has recently been drastically cut, must use dark sky friendly lighting. But that's just a rule. It could be revoked at any point. The Department of Energy has a history of encouraging the use of LED lights to save energy, but they didn't do a great job at setting up their initiatives, their incentive programs. And we have argued that, in fact, what's happened is we've just gotten more light because it's cheaper to make. And instead of saving energy by using the same amount of light but less energy to produce it, we're using the same amount of energy and producing a lot more light. And some of our work has included in the last couple of years researching and crafting a long letter or a short report to the DOE arguing we can do better, we should do better, let's work together on that. We've also updated the AAS's resolution on light pollution. And finally, we are now working with Congress to craft and draft light pollution legislation. For a while, we sort of avoided it, assuming that Congress is anti-regulatory, but we've gotten some encouragement from several quarters, several of our friends in Congress, that it certainly ain't going to happen if we don't file a bill. So we are working on a bill. There was actually a bill in the works last session that we hope to dovetail on. Now it looks as if we might have to just start from scratch, but that's where our efforts are going right now. That was a very quick summary of some of the activities of our light pollution subcommittee. And now, Michelle, you wanted to say a few words about the upcoming workshop at the AAS meeting.
Thank you. So are you going to AAS 246 up in Anchorage, Alaska? If so, please consider registering this week for the workshop that two light pollution subcommittee members, myself and Nancy Clanton, she's a lighting designer, are hosting. It's called How to Get a Dark Sky Friendly Lighting Management Plan Approved on Your Campus. So maybe just like national legislation, your campus doesn't even have anything about lighting in it. And so we've both done work to help campuses get a lighting management plan that's dark sky friendly, secured, and we want to help you learn how to do that. So we'll have an interactive educational workshop, and please consider registering this week.
Okay, up next with electromagnetic interference is Sarah Marie Bruno from Johns Hopkins University. Take it away, Sarah Marie.
Thank you so much, and hello everyone. I'm a research scientist at Johns Hopkins, working primarily on instrumentation for CMB cosmology, and I'm one of the co-chairs of the subcommittee on electromagnetic interference, along with Josh Redding, who is also here online today. I'll briefly introduce what the Electromagnetic Interference, or EMI, subcommittee does as a part of COMPASSE. There is a breadth of services that make use of the radio spectrum. One of these is radio astronomy. We observe radio waves to further our understanding of the universe, from studying individual celestial objects to large-scale structure and the dynamics of our universe. We are passive users of the spectrum, meaning that we receive signals without transmitting signals of our own. We observe in a wide range of wavelengths, accessing a broad bandwidth across different observatories and instruments. And our science depends on our ability to access clean spectrum free from both terrestrial and satellite-based emissions. Meanwhile, radio communication services are active users of the spectrum, transmitting and receiving signals in order to enable communications such as television broadcasting, cell phone communications, and more. We use these services every day, and they're crucial for keeping us safe and connected in an increasingly globalized world. If you can change the slide, please. What I most want to emphasize is that the radio spectrum is a limited natural resource. Because the spectrum is so heavily used on Earth for radio communications and other active services, access for passive scientific research is severely limited. Next slide, please. This brings us to the need to regulate use of the spectrum to facilitate effective use of this limited resource. Frequencies below 275 gigahertz are regulated at both the domestic and international levels to ensure both passive and active services have access. On this slide, you can see the United States radio frequency allocations, and I certainly don't expect that you can read all of these tiny little boxes, but I wanted to show this colorful chart just to demonstrate the complexity at play and how there are so many different services vying for access to the spectrum. Radio astronomy is only a small sliver on this chart. And then if you can change the slide again, managing the radio spectrum is a dynamic endeavor. Radio astronomers have long participated in this work to protect our science, and we should continue to make our voices heard as the landscape of spectrum management evolves. On this slide are a few of the main activities our committee engages in, as well as a list of topics of interest to our group. In the interest of time, I won't read or go through all of these bullet points, but I do want to highlight that one of our priorities is keeping up to date with and responding to FCC filings and public comment periods. We recently submitted a response on behalf of COMPASSE as part of the FCC delete docket in response to a proposal that would lessen the requirements of the radio quiet zone in Green Bank, West Virginia. This, of course, would have a significant impact on the Green Bank Observatory, and so we saw fit to respond as astronomers. I would also like to emphasize that the scope of our subcommittee is multi-wavelength. We wouldn't want mitigation efforts that improve access for radio astronomy to negatively impact other areas of astronomy and vice versa. So our advocacy approach has been to bring together voices from multiple subgenres of astronomy, because we truly are all in this together. And as I conclude, I'd like to shout out the other co-chair of the EMI subcommittee, Josh Redding. We would both love to chat with you and are more than happy to answer any questions you may have. Thank you so much.
Okay, thank you, Sarah Marie. And next, we're going to combine a couple of areas that COMPASSE works in into one presentation to be given by Connie Walker, who is from the United States National Science Foundation National Optical Infrared Astronomy Research Laboratory, or NOIRLab for short. You don't hear the whole thing spoken out loud very often. And she's going to be delivering some remarks about space debris on behalf of our space debris chairman, Pat Seitzer from the University of Michigan, who unfortunately can't be with us today. So take it away, Connie.
John, thank you. You spelled out NOIRLab perfectly. Nobody usually can. So thank you very much for the introduction, and hello, everybody. I'm, as John said, I'm presenting some slides on space debris on behalf of Pat Seitzer, who is very much an expert in that area and chairing that particular subcommittee. And then I'm going to provide the status, basically, of the impact of satellite constellations and all these other, most of the other groups that you're hearing from today are also invested in try to mitigate the situation with satellite constellations. So it's not just any one group that does anything. So kudos to them as well. This plot here that you're, oh, next slide, I'm sorry. This plot here that you're seeing is a population of various objects in Earth orbit as a function of time. And those are actually the ones that are tracked, that are bigger than 10 centimeters. The various ASAT tests and major collisions are shown here, and they're like a big jump in the curve there, as you can see. And the rapid increase of spacecraft, as they're labeled there, since about 2019 is largely due to the Starlinks. And we'll mention that more in a little bit. There's like 7,400 active Starlinks right now. The spacecraft curve includes both active and inactive in this particular slide. The European Space Agency estimates that there's about 1 million objects between 1 centimeters and 10 centimeters in size, and potentially all of them are lethal to active satellites that are up there. Next slide, please. Okay, so the most significant debris news recently is the reentry of the Soviet Cosmos 482 Venus lander on May 10th. This was there were 2 of them that were launched originally. One made it, and this one didn't. It was designed to soft land and survive for a period of time on the planet, because it's very dense and very a hot atmosphere, so it doesn't last for very long. But that one didn't make it out of orbit, and it was left in Earth's orbit after a booster basically failed. No reports of damage as it came back into the atmosphere recently, and it's no longer detected. So we didn't know where it was going to land, and now we know that we didn't land anywhere that's populated, at least. So and other objects are re-entering on a daily basis as well. So next slide, please. Here are some recent debris events as well, going back to June 26th of last year, so almost a year ago. And you can see there were 5 major events, like Intelsat, an Atlas V Centaur rocket body was launched, and Long March 6A rocket body. And DMSP was a Defense Meteorological Satellite Program that provided a lot of nighttime data for us in terms of light pollution. That's also fragmented. And June 26th, there was another satellite, and I don't think I'm pronouncing this very well, Resur P1. All of these have are recent debris events. So, and next slide, please. Okay, so there's a lot of maneuvers that go on, and SpaceX uses very conservative thresholds in this regard. And there's no reported Starlink loss or damage from collision, but there's still things going on up there. There's so many maneuvers each day. There's something like 10 maneuvers per satellite, and remember, there's 7,400 Starlink satellites up there, so per day happening on average, and it's a lot. So about 50,000 or more propulsive maneuvers that are reported over a 6-month period. And so much going on up there, and it's becoming quite crowded, let's just say. So I'm going to turn my attention now on the next slide to active satellite constellations in low Earth orbit, or LEO. And as as recent as a week ago, we had, in terms of active satellites, over 11,700 operational, basically, satellites orbiting our Earth in LEO, and 7,400 of those, as I mentioned, are Starlinks. And so this is an amazing curve, because you can see since 2019 how drastically it has spiked, and that is a crucial concern in terms of how it impacts astronomy. And let's go to our next slide here. And what I mean by how it impacts astronomy is in terms of the number and how bright they are. And I don't just mean the brightness in terms of optical, it's also in the radio. So this page represents just the tip of the iceberg. I couldn't, in this time period that I have, mention everything, and this page doesn't really do it justice. But you can see here in the optical, for instance, satellite constellations have not reached the desired threshold of 7th magnitude. I can't list all the numbers, but basically it hasn't reached a brightness that's just a little bit beyond what the human eye see. In the radio regime too, they're still dealing with things like unintended radio electromagnetic emission from satellites like SpaceX, who don't intend to do that, but their electronics on board are radiating in the radio wavelengths. And then there's along the line of sight things that their missions are trying to avoid as well from satellites. But the companies like SpaceX are trying to mitigate these things in both the optical and the radio. and there's a lot of examples of that. And then there's with the 42,000 Starlinks that are on the horizon, we hope drastically that we can succeed, or they can succeed too, in getting the the optical brightness as low as 7th magnitude. So you can see here, it's not just Starlink, but there's China's 1,000 sails, and phase 2 is now being launched, and they could have potentially up to 15,000 in the next few years. And Golden Dome is something that's coming, we're hearing about a little bit more and more, and it's a missile defense shield. Who knows how bright that's going to be, and huge. Amazon started launching. They now have 29, well, 27 that are up there. The first 2 were prototypes, had different kinds of mitigation, brightness surfaces on them to test them. And they're going to be about 600 kilometers in altitude. And then there's a direct-to-cell satellites. There's AST Space Mobile, who has had a bunch of launches, and the first few are extremely bright. The first one rivaled brightness of Vega, basically. And then Rocket Labs is now confirming plans to do what they call direct-to-cell as well. So big, huge platforms that are going to have lots of phased array antennas on them, and potentially could be bright. But I think we're talking to these companies and trying to make a difference. And then, of course, there's other things on the horizon, like solar energy satellites. And we've talked to Reflect Orbital. And they now have $20 million recently that they've raised, and that's probably at least 4 satellites that they can launch in the near future. Next slide, please. Okay, so ongoing mitigations. I'm going to give you just 2 slides and then that's it. But I want to just tell you some of the things that are going on basically worldwide out there. But many of us in COMPASSE are actually working with the Center for the Protection of Dark and Quiet Skies, or called CPS, in a variety of ways, including satellite mitigation. And I'll just going to touch here on addressing some mitigation strategies with the impact of satellites on our particular field. There's a group in CPS called SatHub that addresses software development and observations, and they're bent on answering the question in terms of software. Where will the satellite be visible from my location, and when, I should say. So it's a position prediction thing during whatever set of time you might be observing. They also have a program called has a field of view service that also with a program they call Sat Checker, which aims to answer the question, what satellites are overhead tonight in their particular field of view of any telescope around the world. So this will be free software, and it's already online. I have the link there if you'd like to access it at some point, take a picture and access it. And then SCORE is another wonderful piece of software they've written. It's a data repository, and you can submit your observations there. Right now it's in the optical, and soon it'll be hopefully in the radio as well. And the latest observation from Amazon Kuiper shows a magnitude, for instance, of 5.8, which is the new Kuiper Amazon satellites, and it's brighter than we'd like. But again, we'll be working with that company, and hopefully things will happen. And then there's other things here, but I think I should probably go on to the next slide. But let me mention this: all these other companies that were there that are also participating in discussions. Thank you. We can go on the next slide. Okay, so this is my last slide, and it's a little bit more on mitigation solutions or techniques or strategies. And the next one I want to talk about briefly is the industry hub that's also as part of CPS. But this hub is inviting people from around the world, these companies from around the world, to participate. And it's like 16 major companies, and I could list them, but you might know most of who they are. And they are satellite companies, and also manufacturers are starting to invite, that are talking to each other and trying to share solutions and concerns of the astronomers, and trying to come up with techniques. And the Astronomer Guides program is another cool thing that's being developed recently. And there's a half a dozen companies where we have actually been able to partner astronomers. And if you're interested, let us know, with companies. So they can also talk and get insights to each other's culture, and come up with some foster the implementation of mitigation techniques too. And there's another concern that we've been working with NSF on FCC agreements with these companies that are, it's facilitated by NSF, the National Science Foundation. And there's about nearly about a half a dozen companies that have signed these kind of commitments, but we don't know with the present administration whether this is going to continue and who's going to be actually supporting this endeavor. So stay tuned on that. And then there's the engagement committee, which this is CE, community engagement, which is run by John and Jessica. They have done a huge amount of work in terms of communications and education. One cool thing that's shared with CPS is their satellite SATCON 101 videos. There's also a VR set that's been in various AAS meetings now, or it's going to be in this one, I hope. It shows, how many satellites are up there right now, and it's like mind-boggling if you ever get to see it. And there's a possible planetarium show in the future. So stay tuned. A lot of cool things are happening. And there's a lot of conferences and publications that are even coming online, let alone the things that have happened. There's publications. I give you 2 sites here, one of which is the COMPASSE publication site, which also includes the upcoming meetings. One that's not quite listed yet, it's brand new, is the radio astronomy workshop coming up in June in Grenoble. And then there's also the policy group, which you're going to hear from next. And so I don't have to do anything on that. And that's going to be led by Richard Green. Okay, take it away, Richard.
Thank you, Connie and John and everyone. Good day. So the next slide will show you that you have heard without question the deep expertise that relies in the subject matter subgroups here in COMPASSE. So the policy group is an enabler to make sure that their technical concerns are presented in the most impactful way in the public policy setting. I guess that's what I would say. So that if we are concerned, Colin gives us an alert that there's congressional language in the works that's relevant to us. We want to make sure we have an appropriate input. We help Sarah Marie and Josh and their group word the FCC reactions so that they hit the hardest. There's process. The AAS, when they send out a letter over the president's signature on behalf of our entire professional society, they want that to be very well vetted and to have both a firm technical basis and, again, a high-level policy impact. So the current president, Darren Norman, has asked that when our group comes up with a technical recommendation, it gets reviewed by the other policy committee, the Committee on Astronomy and Public Policy, which then makes a recommendation to the Board of Trustees for their consideration. And finally, the president can put something forward. Well, that's a very deliberate and deliberative process, and it's not fast. And the world that we're in right now has a lot of things happening very rapidly. So we wanted to figure out a fast track method to have the highest level endorsement that we can, namely the AAS itself, rather than our working committee. And so there is a route where COMPASSE develops some policy statement or some reaction to a congressional bill in the works. We run it by HAP, which has set up a fast track review mechanism. And the president then will actually submit this on behalf of the AAS. However, that has to be done on the basis of an articulated policy or resolution at AAS level. And that's where I think the policy activities in COMPASSE has been the strongest in the recent past, because we're trying to get the AAS on record in supporting regulating satellite constellations, or at least having a process for negotiation for minimizing impact on satellite constellations, for endorsing certain approaches to light pollution, and so on. And so that means that in the midst of our political firestorm at the moment, there has been a more deliberate process where COMPASSE has been looking at and updating resolutions that the AAS passed long ago to try to bring them up to modern relevance. And so the next slide will show you just some examples of what we have been doing recently. And so these are 5 things that are on the agenda for next month for the board to consider. And if those are put in place, then we have rather a robust framework for quick approvals to say, rather than our individual signers or COMPASSE as a committee, it is our professional society that is endorsing these positions. So the first one is wonderful and relatively benign. The last time the AAS endorsed International Dark Sky Week, it was National Dark Sky Week, and it was 2003. So we just said, it's time. There is now a wonderful international activity that really reaches the public. AAS should be foursquare in favor of it, and they are. The next one is also a needed update, I think. The last time the AAS went on record to protect radio frequencies was 1995. And that was a very narrow resolution about a particular band, in fact. So now we are proposing an update to that resolution, which says that radio quiet zones need continuing protection. And in fact, as do radio telescopes quite generally. And given that radio transmissions are zooming overhead, that's a real issue. That there are these concerns that, as Sarah Marie said, the more information we can get about the satellites, the more mitigation we can plan, and they would like to go the other way and not tell us anything about their power transmission pattern, and so we want to protect that. And in the end, there are very few, as Sarah Marie pointed out, protected frequencies. Redshifts put all molecules everywhere, and so we need to work out, as the spectrum is more and more densely used, some way of arranging that if that radio telescope wants to work in a commercial frequency for a time, let's trade. Let's talk about you're not transmitting for that half hour of observation, and so that we have a smart system that can do trades, and that needs more technical study. The most recent light pollution one is from 2017. And so we're calling our whole society to action to implement the principles of Dark Sky International about what proper outdoor lighting is. And in addition, there have been important studies like the Dark and Quiet Skies workshops, which have a modern approach to controlling light pollution. And we would like the AAS to endorse these positions so that we can then go, and when James has something to present for legislative language, it can be AAS endorsed automatically because they have this on record. Connie told you the problems of satellite constellation. Everybody wants to know, what are the thresholds? How many satellites are too many satellites? What brightness really impacts us? What programs are quantitatively impacted? So we need to do a lot of studying as a field. And finally, Connie told you about the CPS. They issued a call to action of what kind of studies are needed on both the industry side and the astronomy side in order to take practical steps to mitigation. And so if AAS endorses this international approach, then again, we're on record and we're in good shape to take quick action on behalf of the whole AAS. Thanks.
Okay, and last but certainly not least, Jessica Heim, who's with the University of Southern Queensland in Australia, will tell you about what the Community Engagement Subcommittee is doing. So Jessica, the floor is yours.
Okay, well, hi everyone. I'm Jessica Heim, and I serve as Vice Chair, along with John Barentine, of the Community Engagement, or CE, Subcommittee. I'm a PhD candidate at the University of Southern Queensland, but as I'm studying remotely, I continue to live in the US. Next slide, please. So the purpose of the CE subcommittee is to engage with the AAS membership on light pollution, radio interference, space debris, and satellite constellation issues. We facilitate communications about COMPASSE activities and related information to the broader membership. The CE subcommittee aims to enable our members to, 1, become more knowledgeable about light pollution, radio interference, space debris, and satellite constellation issues, and 2, be able to more effectively engage with these issues and contribute to meaningful solutions. Next slide, please. Our largest project to date has been the launch of the COMPASSE website, compass.aas.org. On this site, you can learn more about all the topics we've been discussing today, access educational resources, and keep updated with the latest developments. Next slide, please. For example, the AAS has produced fact sheets about ground-based light pollution, satellite constellations, and radio frequency interference. These fact sheets are a concise introduction to these topics and are useful for sharing with students, policymakers, and anyone else interested in understanding the basics of these issues. Additionally, we have links to videos of past COMPASSE events and to external resources that provide further information on COMPASSE-related topics. Next slide, please. We also share success stories of places where improvements have been made to outdoor lighting and communities have become more engaged in learning about and implementing responsible outdoor nighttime lighting. Next slide. In addition, we highlight a variety of research papers, media stories, and upcoming events related to light pollution and space environment issues. By compiling these resources, we hope to provide a useful one-stop shop for those who are interested in keeping informed on ongoing developments in these areas. The CE subcommittee will continue to add resources to the website. We are also working to more proactively engage media with COMPASSE themes and guests. For example, we are compiling a list of dark sky and astronomy podcasts and plan to pitch podcasters with story ideas and potential COMPASSE guests. The links to these materials will be added to the COMPASSE website as they are created. Next slide, please. As discussed earlier, the main goal of the CE subcommittee is to enable society members to become informed on the topics we have discussed today and to provide them with tools to engage with these issues so as to be able to contribute towards meaningful solutions. We hope that today's webinar has helped to contribute towards these aims. If you would like to hear from COMPASSE more frequently, please do sign up for our mailing list, and the website and the QR code is up on the screen. Don't worry, we will not flood your inboxes. We intend to send out a newsletter several times a year and also inform you of periodic COMPASSE events, for example, sessions at summer and winter meetings and any additional informal online events that we schedule. So I just wanted to thank everyone again for coming today. And now we're going to shift into time for Q&A for the remainder of this event. And as a reminder, just use the Q&A button to type your question into the Q&A box, and we will get to as many questions live as we can, and we'll also type answers back to those that we cannot address live. So, John, why don't you take it away? What do we have for our first question we'll look at?
Okay. Yeah, and we've got some questions that are already being answered in the Q&A box. There's a few that I'm going to pitch to some of the speakers to answer live. And let's start with this question, which I think would be for Connie, about satellite mitigations. The question is that I understand that SpaceX has blackened the downward or Earth-facing side of Starlink going forward. And while that's not necessarily a complete answer to the issue, especially for research, what do we think of mitigations like this one, and are there others?
Yeah, there have been. This is not actually blackening, but it is darkening. It's a certain paint they use on curved surfaces, and on a flat surface they use like these little mirrors that kind of reflect light away from the Earth. So those methods of sharing, they're very willing to share at cost to other satellite companies. And I think there's at least a couple that have looked into using that technique. There are also things like sun shields that they tried, but they didn't allow for them to have laser communications between satellites. And they had initially a black paint, which basically heated up their electronic components. So those two last ones they dismissed. Those are the first two they tried, and now they're settled on this. It looks like a blue paint actually, and the mirrors, but that's not quite getting down to the 7th magnitude threshold that we'd like to see in order for that us to be able to basically mask without any, it'll be like a linear streak across the images instead of changing its width, because once it changes its width, it has some residual errors that it's very hard to take out of the image. So anyway, so we're trying to get them below this particular limit. And again, kudos to SpaceX for being willing to share these kinds of solutions. Anybody that might be able to use them. Does that answer your question sufficiently? Okay.
That sounds pretty good. Thank you for that.
Mm-hmm.
We have a question that I think is probably best for James, that has to do with retailers of outdoor lighting products and how they advertise, how they promote products in their stores, and whether there's anything that we can do to increase the awareness among retailers, because of course they're the sort of the front line, anything that goes to consumers. So how can we help them to help consumers make better choices about lighting?
Thanks for that. Good question. You're absolutely right. That's the first place that consumers may experience any literature or messaging or products regarding dark sky friendly lighting. Otherwise, they might just go to Home Depot or Lowe's to buy a garage light or a yard light, and they'll see one that advertises itself as super bright and think that that's best and just buy that. And that's typically what happens. And there's a profusion of consumer lighting that is terrible for the nighttime environment. It's just proliferated like crazy in the last 10 years. So what are we doing about it? There are, of course, at big corporations like Home Depot, there are always environmental offices, and Dark Sky International, which is not us, but we're friends, has for the last more than 10 years been trying to cultivate relationships. They actually have representatives from some major retail stores, like big box stores like Home Depot, represented on the Dark Sky board to really try to make sure that the communication is as open as possible. Dark Sky International, not AAS, is the organizer of a major effort to make the information available. What are good fixtures and what are bad? So they have a dark sky friendly, dark sky approved fixture program where thousands and thousands of fixtures are vetted by Dark Sky for their dark sky friendliness. But that doesn't mean that that filters into the stores. So barring all that, the only other solution is regulation, and we don't have any at the national level, but we do have it at the state level and the local level. So if you don't have it in your state or your municipality, that's an opportunity. And there's a lot of work going on every day. Every day there are more municipalities in the United States that are passing dark sky bylaws or ordinances. And there's ongoing work at the state level as well. So join that or start it, and we can help you. There are templates, the language is ready to go. There's a lot of work that's gone into making it easy, lowering the bar so that you can get those regulations in wherever you live as well. And once that's in place, then it's much easier to go to a big box store and say, look, 90% of the lights you have here are not compliant, and let's talk.
Great, thank you, James. That's a good answer. We have a question here that I think it could go to a number of people. So I'm going to put this out here and see what people think. Maybe the co-chairs. And the question is whether there are efforts to collaborate with other professional societies. And some examples that are given range from the American Medical Association about health effects of light pollution, the AGU, the American Geophysical Union, on the environmental effects, or the Astronomical Society of the Pacific. And I see Connie nodding her head over there, that these could all provide support. So does anybody have any thoughts about that?
But go ahead, Connie, if you'd prefer.
No, go ahead first, and I'll go after if needed. Okay.
Okay, we totally agree. And a hard-learned lesson that astronomers must embrace is that we cannot fix light pollution alone. And we've tried it for more than 30 years. We've tried it essentially in our silo as astronomers. Why can't everybody understand that we need to preserve the dark skies so that we can see the stars? That is still true. And it's true that most people want to see the stars, but it's probably not going to fix the problem. And we found that out the hard way. It's even hard just to get lots of, enough astronomers to pitch in. But look what a great group we have here today. So it shows it's possible. We now recognize that really we need to partner with exactly what was pointed out in that question: human health advocates, advocates for the environment, advocates for saving energy. And we are doing that, and um, we've been cultivating relationships with the Sierra Club and National Audubon Society and the American Medical Association, as you mentioned, and we have actually reached out to geoscience communities as well, and involved them in our workshops to solicit their feedback on how our messaging is doing, and you know, how we could expand our messaging into their realms. And we reached out to the architecture community and for feedback from the built environment professionals. And so we're maybe at the early stages, but I completely agree that that sort of interdisciplinary approach is critical. And as Michelle will tell you, if you attend her Campus Shine workshop at the AAS meeting, Campus Shine is not explicitly an astronomy initiative. It is explicitly interdisciplinary. Anybody in any field could pick up our how-to document and use it to try to move light pollution control forward on their campus.
Okay.
So thanks for that. Really good point.
Yeah, and I was going to say something very, very similar, but just to add, you know, if you go to the public really is the audience, the community we want to convince, because they're really going to help move things forward if they are convinced that it's a problem. But you can't say, oh, we want to protect astronomy and leave it there. You have to say how it is relevant to their lives. And it's relevant in terms of energy consumption. It's relevant in terms of you know, the animals that affects. It's relevant in terms of their health, safety, all these things. And so if you know, these are the ways we have to pitch things and connect to the communities or the organizations that deal with these issues. And so, you know, what James said is exactly right, and exactly the kind of path we're trying to take. Thank you. Aparna?
Thank you, everybody. My name's Aparna, and with Tesney Pugh, I'm one of the outgoing co-chairs of COMPASSE. And I just want to first honor everyone who's taken the time to be here today, and also our amazing speakers and panelists. And over the last few years, it's been a primary goal for COMPASSE and for me and Tesney to not just partner across disciplines and professional societies, but to learn from each other. It's near impossible to keep track of all the implications of what's unfolding and all the issues and advocacy arenas that COMPASSE is involved in, and learning from each other is key. We've learned a lot from everyone that Connie and James have mentioned, and also from, you know, for example, atmospheric scientists, you know, just what are the impacts of all the re-entering satellites, and soon we'll need to learn from a broader range of disciplines, and including planetary scientists as we move farther out and the same issues become important on the moon and beyond. So just really want to honor that. Thank you.
Okay. So we have a couple of, well, there's a question here and there's a related comment, and I think this could go to a couple of people as well. I'll start with Connie. And that is because I think it's aimed more at the satellite constellation issue. And that is, what impactful efforts do you see being done by amateur astronomers to add to data gathering for publication and other activities going forward? And the reason I'm going to send it to Connie is that I think that there's a broader concern here as well that touches on other areas like light pollution. And the comment is that it would be good to connect with amateur astronomers via organizations like the Astronomical League, because in many cases, amateurs are more aware of the degradation of the night sky than professionals.
Mm-hmm. Yeah, I agree with you totally. We have to do a better job with that connection to the amateur community. They are incredibly involved at this point right now in the center that I told you about, CPS, in taking observations of satellite constellations, for instance, but also just in doing things for the sake of light pollution. So you will see, if you look, for instance, in that the two links that I provided you, one is from Zotero, just if you put like light pollution or satellite constellation in the link there for Zotero, you will find the papers, and a lot of them have been involved with the community here, a lot of them, and with CPS as well. And a lot of them, I'd say probably half of them are amateur astronomers that have made a difference. And so, yes, we have to reach out more, because I think there is a little bit of apprehension on the parts of the amateur astronomers, because they see the professional astronomers, at least with companies, not companies, organizations like CPS, as being too sided with the industry. And that's just one way of tackling the problem, not being sided with the industry, but working with the industry, taking that one pathway. There's many pathways. If we can somehow reach out to the astronomical community and see that we're doing this for the endeavor of their needs, professional astronomer needs, and the needs of society in general, I think we will win their confidence, at least. So I hope that answers the question. But also, John is very good at this question too. So you should actually be answering this, not me, John.
Well, I mean, yes, we very much do want to work with the amateur community, and we're looking for opportunities to do that as a real significant force multiplier. And whether it's, light pollution with globe at night, or whether it's making observations of satellites, there's really valuable work that amateur astronomers can do. And we're increasingly sensitive to the fact that they're a bigger part of our society as well, the American Astronomical Society, that even though people still think of it primarily as a group of professional astronomers, that more amateurs are joining. And we really do want to welcome them into participation in the full spectrum of activities that AAS is involved in. So it's the suggestions are very much taken to heart. And to the extent that people who are listening to this today have connections with those organizations, we would absolutely love to talk to you about those possibilities. We have a couple of more questions and about 4 minutes until the top of the hour. I've got one here that I think probably would best go to Richard, because it sounds like a policy question. And it has to do with the issue of demisability of spacecraft. And the question is, what is happening internationally to enforce demisability? So maybe would you start off by explaining what that is?
At least the ongoing supposition is that a low Earth orbit satellite, for example, has a finite lifetime, after which its mission is complete, and there should be a controlled reentry that allows a complete burn up of the satellite so that pieces don't knock civilians on the head or worse. And so as part of the licensing procedure in the US, for example, from the FAA, they have to demonstrate that in all likelihood, their entire satellite will completely burn up on its controlled reentry path. And there are other launching states, and the IAU Policy Hub has just put out a review of international regulations, which we can point to. So I do not know what New Zealand's launch, they're among the top 3 or 4 launching nations. And so each nation has a set of requirements like that. The human casualty issue is a real one. The irony is that we do not know what the possible change in upper atmospheric chemistry might be in the high frequency of reentries as exotic materials are deposited on the way in. And so we as a society have been advocating for funding to study that by our professional colleagues who understand that field. And interestingly enough, the current administration has actually pulled those specific grants, and so that they don't want to know if there are actually global impacts coming from that. So there is a best practice and best policy in place. Its very basis is being questioned, and we need information. And Sam is very expert on this, so she should add a word.
Yeah, so I'll just add that I have now seen, so full demisability is the idea, right? That satellite companies are going for. I've now seen pieces of 2 SpaceX spacecraft that are supposed to be fully demisable that have hit the ground here in Saskatchewan. So they're not fully demisable. And even if they are fully demisable, with the very short lifetimes and the huge masses and fluxes of these satellites, the amount of metal that will be deposited in Earth's atmosphere is truly terrifying, right? Like, light pollution and radio pollution from satellites makes me very sad, but what keeps me up at night is the metal pollution in the atmosphere. And this is where, yeah, like Aparna said, we need to bring in atmospheric scientists. We're not atmospheric scientists, but this is the next big scary thing. And this really highlights how the satellite industry needs to move to using fewer satellites with longer operational lifetimes. Absolutely, right? That is the engineering challenge that we're up against now. Go ahead, Sarah.
Thank you so much. And I actually wanted to bring up a slightly different topic. So I'll pause just in case there's anything else to add on the demisability topic before launching into something slightly adjacent. If not, I wanted to discuss briefly some of the aspects around different subgenres of astronomy and making sure that mitigations that help one aspect of astronomy don't cause problems in other aspects of astronomy. And just thinking about how important it is to have fora such as this one for astronomers observing in different wavelengths to communicate on all of these issues. I wanted to bring up kind of a historic example at this point. There was an early proposal a few years ago now to darken Starlink satellites using black paint. And this mitigation effort was in collaboration between Starlink and optical astronomers. And when it was tested, it was found that it did indeed significantly darken the satellites and make them a lot less visible to optical telescopes on Earth. But this mitigation was ultimately scrapped because it caused the satellite electronics to overheat. And in retrospect, now we realize that this overheating would have caused the satellites to emit blackbody radiation visible at other wavelengths. So it might not have really been the best solution for astronomy as a whole. So I wanted to bring up how important it is to gather data and just for all of us on this webinar as astronomers to use your telescopes to gather real-time data as to whether you see interference from satellites and other emitters, how that's actually impacting your science, propagating from the data to the actual science outputs. The more data we have, the more we really understand the types of mitigations that will be most beneficial across the board. And I wanted to highlight a comment in the Q&A box from Chris Dupree at NRAO that NRAO has built and has operational a system called Operational Data Sharing, or ODS, which enables spectrum sharing in the 10.7 to 12.7 gigahertz range to allow some testing between the VLA and SpaceX to see what can be done in terms of data sharing and kind of modernizing our approach. So just wanted to highlight that, and there's a link to a couple papers there that I encourage everyone to take a look at. Thanks so much.
Okay, since we're now a little bit over the top of the hour and we want to be respectful of your time, I think we're going to go ahead and call it a wrap at this point. Thank you for your attendance today. Thank you to all of our speakers for participating. We have recorded this conversation today, and we will find a way to make it available probably through the COMPASSE website. So if you want to go back and review any of it, you'll be able to do that. And unless anybody has anything else to add, I think we're going to go ahead and get you on your way today. Okay. All right. Thank you, everyone. We look forward to seeing you in Anchorage. Have a good day and goodbye.
Thank you.